Okay, so we are asked how to determine how many of these are polar, and we're given SO3, OF2, BeCl2, CCl4, and O3. So the first step in figuring out which of these are polar is to draw the Lewis structures. And I'm going to start with the SO3. So we're going to have the S in the middle and the 3 O's on the outside. This is because the S is the least electronegative, and these are the most electronegative. And we know that this has 24 valence electrons, and we are going to distribute them to make octets on the outside atoms. Now, when dividing these up, we also have to make sure that we have an octet on the center S. So one of the oxygens is going to have to make a double bond with the S. So now we're going to see which way our dipoles are facing. And so our dipoles for this molecule will be going towards the most electronegative atoms, which are the O's. And for this molecule, the molecular geometry is trigonal planar, and it has 3 of the same domains on the outside. And since the domains are all equal, this means that, since they're all the same, this means that the dipoles are going to cancel, and there's going to be no net molecular dipole, which is going to make this molecule nonpolar. So our next molecule is OF2, and we're going to put the least electronegative in the middle and the most electronegative on the outside. And for this, we have 20 valence electrons, and we're going to make octets on all of our outside atoms first, and then we put the remaining electrons on the center atom. And so for this molecule, the dipoles are going to be facing our F's because they are the most electronegative. And the geometry for this molecule is going to be bent because we have 2 sets of non-bonding electrons on the center atom. Since the domains are not all the same, this means that the dipoles will not cancel, and there will be a net molecular dipole left at the end, which will make this molecule polar. Okay, so our next molecule is BeCl2. So I'm going to put the Be on the inside and the Cl's on the outside because the Be is the least electronegative and this Cl's are the most. And this molecule has 16 electrons, 16 valence electrons, and we are going to make octets on the outside atoms. And since Be is an octet violator, it can have less than 8 electrons, and this means that this is our final Lewis structure and that these are satisfied atoms. And our dipoles for this molecule are going to be going from the Be to the Cl's in this manner. And this means that our molecular geometry is going to be bent. And since there are no non-bonding atoms on the center non-bonding electrons on the center atom, that means that the domains are the same and that they will allow these dipoles to cancel, and this will make this molecule nonpolar as well. Okay, and our next molecule is CCl4. So we're going to put the C in the middle and the 4 Cl's on the outside, because this is the least electronegative and this is the most electronegative. And this atom has 32 valence electrons, so we are going to make octets on all of our outside atoms first. Once this is done, we can see that all atoms have an octet. And so our dipoles are going to run from the C to the Cl's. And our molecular geometry is going to be tetrahedral. And since all of the domains are the same, this means that the dipoles will cancel, and that will leave no net molecular dipole, causing this molecule to be nonpolar. And our final molecule is ozone. And we will put the O's on the outside. And this has 18 electrons. And this means that there will be a double bond on one of the O's. And I'm just going to make it this one. And that is for the Lewis structure only. And so we see here that the geometry would be bent because there is a pair of non-bonding electrons on the center atom. This means that all of the domains are not the same, and that would make this molecule polar. So the two molecules that are polar are the OF2 and the O3, or the ozone. And some common mistakes that could occur would be incorrectly drawing the Lewis structure, and also it could be drawing an incorrect molecular geometry, which would stem from drawing an incorrect Lewis structure.